Swayam Prabha. Digital India. Educated India.
So let me show you the very simple and elegant mathematics behind this. When you have tossed a coin n times and k heads appeared, then we are interested in the probability of head. That is our underlying controlling parameter. So that probability is P. Now the observation probability for us is P to the power k into 1 minus P to the power n minus k. Okay, these are IIDs, identical independent observations. Okay, these identically independently distributed observation. The outcome of toss of a coin does not depend on any other toss. So you can really multiply all the probabilities. Now there are k heads, so P to the power k, and there are n minus k tails, so 1 minus P to the power n minus k. Now this is a function of P. K and n are constants. Okay, n tosses constant, k heads have been obtained, observed, constant. So the only thing which is variable here is P, and we want to find out P by maximizing the observation probability. The observation probability is called likelihood. Now since we have exponents, it is more elegant to deal with log likelihood. So we take log likelihood and we get k into log P plus n minus k into log 1 minus P. Now maximizing log likelihood is equivalent to maximizing the likelihood. So when I take the derivative of log likelihood with respect to P, then I get k by P minus n minus k by 1 minus P. I equate to 0 and then P comes out to be k by n. Okay, so computing the ratio is well principled and it gives me the value of the parameter which I can trust because the principle is very clear. Now, what was the principle here? The principle here is the maximum likelihood estimate. Maximize the probability of the observation. What are competing principles? One of the strongest competing principle is maximum entropy principle. Okay, and maximum entropy principle is to be adopted when we don't have any observation. Okay, when you have no observation, then maximum entropy principle is the only thing you can do. The other competing principle is Bayesian. Okay, there is a very interesting example of the same situation. Maximum likelihood estimate gives you k by n as the probability of head, but Bayesian estimate will give you a different value. Okay, because in Bayesian estimate you have to deal with the prior probability also. So I'll give you an very interesting example of same thing, k heads and n tosses. The Bayesian estimate will give you different value if the prior probability is assumed to be, let's say, uniform or Gaussian or whatever. So three competing frameworks: maximum likelihood estimate, maximum entropy, and Bayesian. Okay, so these three competing frameworks give you the parameter values. So this way of calculating the transition probabilities by ratio and observation probabilities by ratio is based on the principle of maximum likelihood estimate. Please remember this principle. And you have exercise coming out of this. Following the process for finding the probability of head from n tosses of coin yielding k heads, prove that the transition probabilities can be found from MLE. So what I'd like you to do is that prove that the probability of JJ, a probability of NN given JJ, the probability of a noun preceded by adjective is indeed the number of times NN follows JJ divided by a number of adjectives in the corpus. Prove that. Okay. Similarly, the lexical probability of black given adjective is equal to number of times black is tagged as adjective divided by total number of adjectives. So please prove that. Proving this means that you will have to show me the appropriate likelihood expression. Okay, and here you might find it helpful to look at the second chapter of my book on machine translation, which deals with these discussions. Okay, multinomial distribution, multi-Nolli distribution, by Bernoulli distribution, binomial distribution, and how you form the likelihood estimate. Okay, so do this exercise. So now I'll go to the assignment discussion, on which I believe there are many questions, and legitimately so. You should really have challenges and difficulties in doing this assignment. Remember that natural language processing is an empirical discipline. Okay, you have to learn the subject by doing, not only by reading and listening to lectures. You have to do assignments, projects to get a hang of what is NLP. Okay, so it is an empirical discipline. So on the assignment, I believe you have problems about the large number of corpus and large number of tags. By the way, when I say large number of corpus, it is people today will laugh at my statement, because brown corpus is just 1 million words. Hello? Yeah, just 1 million words, that is 10 lakh words, which is very, very small compared to actual practical corpora, which are put to use for many purposes. And there are 500 samples, each of 2000 plus words. And the original purpose of Brown corpus was to facilitate automatic or semi-automatic syntactic analysis. So, there has been questions by students: can we use the universal pause tag set? Okay, so the universal pause tag set is very simple and useful also. I believe it came from Google. Adjective, adverb, interjection, noun, proper noun, verb, adposition, auxiliary, conjuncts, determiner, numericals, particles, pronouns, esconge, I don't remember, punctuation, and symbol. Okay, so a very reduced set of tags. And the TA team told me, and some students also said, that in NLTK there is a tool which converts the brown corpus, annotated brown corpus, into a corpus with only universal tags. Okay, so you are free to, not free to, let us decide that you will work with universal pause tag sets, okay, which is a very, very simplified tag set and very reduced size. There are only about 12, 13, 14 tags, as opposed to 400 combination tags or about 40 individual tags from pen tag set. Okay, so you can use universal pause tag set. I'll put it on the WhatsApp also. And then your task becomes much simpler. Okay, you have to compute the ratio of numbers to get transition and observation probabilities. And when you go to universal tag set, you see this kind of definitions. The noun is defined as denoting a person, place, thing, animal, or idea. This is from the site which I've given on the slide. And if you query Google for universal tag set, this is where you will go to. And noun tag is intended for common nouns only. Proper noun are used for proper nouns, and pronoun for pronouns, pron for pronouns. And there is a note. Note that some verb forms such as gerunds and infinitives may share properties and usage of noun and verb. Depending on language and context, they may be classified as either verb or noun. So here is an example. Swimming is a good exercise. Here swimming is noun. He is swimming. Here swimming is verb. So ing, words ending in ing have this peculiar property. They are called gerunds. So gerunds can function as both noun and verb depending on the context. Similarly, infinitives also. To see is to believe. So to see is to believe. Okay, this is an example of infinitive. So with reduced tag set, this is what happens. A tag can you have reduced the tag set. You have a corpus which is annotated with a reduced tag set. The situation is simpler because you are dealing with less number of states. But these tags, will they be useful for subsequent operations, subsequent stages of NLP? That is a question which needs to be answered separately. Okay, so continuing this way, the description on the universal tax set also gives examples, and the reference is Eugene Lewis, where the linguistic terms uh, are given glosses. Okay, so this is what is to be done for the assignment. So at this point of time, I can take questions. So if questions have been asked on chat box, Diptesh, you can ask those.
The first question is by Varad. He says, can we use Viterbi in cases where Markov assumption does not hold or it's different from one?
No, the Viterbi algorithm is a result of Markov assumption. Maybe your question is slightly different. Your question is that if the assumption is not bigram but trigram or quadrigram, that means a word depends, the state depends not only on the previous state but also previous 2 or 3 states. Okay, if it is not a bigram assumption, then also does Viterbi work? Yes, Viterbi algorithm works then also. Only thing is that the Viterbi assumption kicks in at a deeper level. Okay, not after 2 levels, but after 3 levels for trigram. And you have to choose paths ending in 2 states. Okay, not 1 state, 2 states. Okay, and you find out all those paths ending in a sequence of 2 states, let's say NNJJ or VB, okay, and find out how many paths are ending in these 2 states and choose that path which has the highest probability. Okay, this is for trigram assumption, where a state depends on previous 2 states but not 1 state. But such automata, probabilistic automata, cannot be drawn on the plain paper. Okay, you will have to work with tables and tuples. So Bharat, is that the question?
Yes, sir. I think it has been clarified.
Yes.
Okay,
Okay,
one
next
more
question.
question that Varad has is, so we will first need to learn the probability tables from the corpus using EM before we can apply Viterbi?
No. So as I said, EM is applicable for unsupervised learning situation. Okay. In this case, you have corpora annotated by pause tags. So if you had only corpora, no pause tags annotated on the corpora, then you will have to use EM, and also called the Baum-Welch algorithm. Okay, but in this case, you simply have to take ratio of counts, which is nothing but maximum likelihood estimate.
Another question that Varad has again is, suppose, so Vatsal said that Viterbi pause slides are not part of the shared slides for the week, and I told him that we will update them. We will get updated slides from sir, and we
Yes.
will update them. But next question by Varad is, suppose there is a word which is not part of the training corpus but appears in the test set. For that word, what will be P of O given S? Will it be 0?
So the problem is, if it is, you know that it will be 0 computationally speaking. So let's say you have not seen the word black in the training corpus, and therefore probability of black given JJ adjective is 0. Suppose you assume it to be 0. Now, since you are multiplying by probability, the whole path probability will be 0. But you know that in real life, black actually is an adjective. Okay, just because of the fact that it is not appearing that in the training corpus, that doesn't change the reality. Okay, that doesn't change the reality. It only means that the corpus is not representing the language phenomenon fully. We know that black is adjective. Yes, there is a language reality, but it is not present in the training corpus. That means the problem is with the corpus, not with the language. Okay, so now you are faced with a situation which is 0. You have to multiply by 0, and that will completely be wrong. So now what you have to do is that you have to apply one of the smoothing techniques. So I have mentioned this in the WhatsApp For smoothing, you have to look at the excellent treatment of smoothing in Manning and Schutz's book called Foundations of Statistical Natural Language Processing. So now 0 is not acceptable. So what you do is that I briefly discussed this, but I really want you people to read that discussion on smoothing. It is about 3 or 4 pages of discussion. Very nice, covering good Turing smoothing, add one smoothing, Laplace smoothing, all kinds of smoothing, and you can adopt any one of those strategies for smoothing. If not, okay, if you want to stick to a very simple situation, just add 1 to all the probabilities. Okay, just add 1 to numerator and denominator for all the ratios. Okay, and then whatever has a 0 count, it becomes 1, and the denominator is also incremented by 1. That is called add 1 smoothing. Okay, this is something which is very commonly used in part of speech tagging.
Muhammad Ali Rehan asks us that what feature vectors do we use for SVM? And I tried to answer it by saying that make a feature vector using various word features like vocab count, is the word lowercase or uppercase, and is it prefixed, is it suffixed, is the word hyphenated. So using these criterion, you can form a feature vector, and that feature vector then can help you with classification algorithms like SVM. So
yes, that's a good answer, but I would add to it. Okay,
right.
I would add to it. What you do is that so let us remember this, and I think it should be added to the slides. Okay, I'll add it to the slides, but the TA team, please put it prominently on all the platforms.
Sure.
So what features do words have? Okay, that requires us to go into the level below part of speech tag, which is called morphological
Morphology.
layer.
Yeah.
Yeah. So we did not do morphology layer, but the features are the following. One very important feature is simply breaking the word into 2 parts: suffixes and the stem. So quickly is quick and lee.
Yeah.
Boys is boy and s. Okay, ladies is lady and s. So this way of breaking a word into stem and suffix is the first feature extraction that one does. Next, for verb, you have 6 fundamental features: gender, number, person, tense, aspect, modality. Okay, these are the 6 features for verbs. For nouns, it is number and direct or oblique. Okay, so these I'll put down on the slides, but you start with just a feature of suffixes and the words. Now if the question is how do you get the suffixes, you get the suffixes by using a very simple stemmer called Porter stemmer. P-O-R-T-E-R, Porter stemmer, or a statistical stemmer which is available in plenty from many sources. But my suggestion would be use a very modern technique. This is called byte pair encoding, BPE. Okay, BPE, byte pair encoding, and that byte pair encoding will give you substrings of the word which are very frequent in the corpus. So those substrings will be your features. Okay, so if a word has these substrings, then you represent it by 0, 1, this kind of binary number for that word. Okay, so I think I'll write a small paragraph on this, and stem suffix is the most common feature that should be used. And for nouns you use number, for verbs you use again number, person, tense. Okay, and there are other special features like TION, shun. So these features are very common in NLP when you use graphical models. So I'll again send the reference due to Shah and Pereira, which you should read, or by Ratnaparki, Advait Ratnaparki. Maybe you'll not remember many of these things. I'll compose a a proper small write-up and send it to you.
Sir, none of these encodings are somehow, I think, able to incorporate context. I mean, what came before the word in the sentence. So this is like if we have the word quickly, then this encoding is always fixed for quickly. It never depends on what came before quickly in the sentence.
Right. So when you do feature extraction, features, okay, you put the part of speech tag as a feature, okay, and also the part of speech tag of the previous word as a feature, and the features of previous word as the feature, features of the next word as the feature. So you really have to read part of speech tagging or shallow parsing with conditional random field and maximum entropy Markov model. And my next topic will be discussions on chunking using conditional random field. This will be the next week's topic, and there you will get a better idea.
That would give them a better idea of using previous or next feature.
Features, how you use features. Yes.
One last thing, NLTK library gives you support for two stemmers by default, Porter and Snowball. Snowball, I think, is considered a step ahead of Porter. But as sir said, by all means go ahead and start using BP embeddings for stemming, BP features for BP for stemming, and that should help you do better.
You can use them, but starting with a basic stemmer is also a good idea.
Yeah. So पहले just try and implement using either Porter or Snowball, and see कैसे results, what are the kind of results you're getting, and then please go ahead and by all means use BP. Okay. The next question I think is by Rishi.
Could you also put this list of stemmers names on the group?
एक second. I'll do that, sure. So Porter is one. Then you have Snowball, and these two are in NLTK itself. NLTK provides you the support, but the BP based stemming is something that you should look for in the later stages of your assignment. The next question, sir, by Rishi is, should we process words before calculating the probabilities, like converting all to lowercase?
Yes, that is typically done. Convert everything into lowercase. Yes.
Okay. So in that case, sir, they will lose the capitalization feature for I think proper nouns such as named entities.
Yes.
You can decide on whether to do that or not. And Venkat Sai Baba Reddy has this one more question. Suppose we have two sentences with JJ followed by NN in one sentence and JJ followed by full stop, sentence end. So while calculating P of tag given JJ, should we consider the JJ in second sentence? That is, should we calculate P of sentence end tag slash JJ also, and consider this in calculating P of some other tag slash JJ in denominator?
No. So you should not have this confusion. So probability of dot given JJ and probability of NN given JJ are two different parameters. Okay, they are two different parameters. So probability of dot given JJ is simply the number of times dot is preceded by JJ divided by JJ. Okay, so you keep your concerns separate. First of all, calculate how many times JJ appears in the corpus. That will come in the denominator. Then find out how many times JJ is followed by dot. That will come in the numerator. Find out how many times NN is followed by JJ, or right, preceded by JJ. So for the parameter P NN given JJ, you consider NN. For dot given JJ, you consider dot preceded by JJ. These two are different parameters. You don't have to mix them. Okay, thank you.